Comparative study on airless tire of different spoke structure on aircraft. Abstract: the air-enclosed rubber is packed with pressurized air to form a pneumatic tire. Due to its low pressure in contact, minimum vertical rigidity and low mass design, it is very dominant in the market. The NPT were introduced to overcome the disadvantages of pneumatic, which are complex manufacturing procedure, maintenance of internal air pressure. The NPT doesn't use air to support the load. The main three parts of the NPT are, a rigid hub, deformable spokes, tread, reinforced shear band which have contact with the surface. In this project, the conventional alloy wheel is replaced with flexible spoke structure in a Cessna 172 aircraft. With uni-axial load, we investigated various spokes designed for the NPT. The spokes were designed accordingly to the tire measurements of Cessna 172 aircraft in CREO. Ansys 19.2 provides the analysis. The finite element analysis is used to study about the stresses and deformation in various speaking types. In this project we studied and tested on NPT of pipe, spline, double spline structured spokes. Keyword: non-pneumatic tire, uni-axial load, spoke structures, CREO, Ansys 19.2, Cessna 172. 1. Introduction to non-pneumatic tire. Introduction. Vehicles rode along with cushions of rubber-embraced air for more than 100 years. Sometimes, we become so accustomed to some product that for years or decades no real change has ever been made. This is how our project starts on the development of airless tires, which in the last few years has become increasingly prevalent. A few non-pneumatic tire designers, including Michelin and Bridgestone, have started to experiment, but neither design has made it into mass production. Non-pneumatic tire. The development of a new non-pneumatic tires, as one might think, will have more positive effects. There are huge safety advantages. With an airless tire, there are no blowouts, so road accidents can be considerably reduced. It has a solid internal hub, which is attached onto the axle of the vehicle, and is enveloped in polyurethane. This forms a wedge pattern that can absorb road effects. These spokes are similar to that found on bicycles and are like a traditional pipeline to shock absorb the air of the compressed air. Then a simple band is extended over the spokes that form the outside edge of the tire. The air pressure used on traditional pipes is supported by the band voltage and the strength of the spokes. For example, if a car drives across an obstacle, the tread and shear strips bend when the spokes bend back into shape, before they rebound quickly. 2. Literature review. Mohammad Faisalpour 1 was concerned with the study of mesostructures in the development of the non-pneumatic tires shear band and concluded as below. To increase NASA manned exploration system fuel efficiency, they substituted elastomeric material with shear band shavings with materials that can withstand harsh temperatures and shear loads, or replacing the material by linear elastic materials with low hysteretic loss. Shear straps of non-pneumatic tires, which included the use of mesostructures, shear strains, and contact pressure, were investigated through the implementation of new forms, including S-type mesostructures and structural analysis. In the final analysis they set out guidelines on custom mesostructural designs for challenging applications, for example the non-pneumatic tire, and the passive morphing airfoils. In search of yielding spoke structures, A.M. Abolyazid 2 examined 3 different Twill structures, resistance technologies, and NPT. The quasi-static 2D analysis of pressure, vertical tire stiffness and stress, which are influenced by spokes and shear belt, were done by creating a tire with a composite ring and a tire without a composite. The results showed that spoke S-shape and size have an effect on tires, and the shear cap reduces the impact on the contact pressure distribution of the deformed spoke S-shape. In its life cycle from assembly, through use, and transmission, Bert Bras 3 discussed the ecological effect of the Twill tire. Since the Twill tire remains in the testing stage and most definitely not produced and used in large measurements, there are instabilities as regards end-of-life situations and assessments of rolling resistance which will affect the LCA. Problem definition. Non-pneumatic tires are generally more rolling resistant and have significantly less suspension than pneumatic tires in similar shape and size. Added, airless tire problems contain heat dissipation that occurs when driven. Non-pneumatic tires, as compared to air, are often packaged with compacted polymers. Taking into account the non-pneumatic tire structure, spokes are compressed and tight while they roll in cyclical loadings. Therefore, the localized stress of spokes must be reduced, which means that spokes must be tiredness resisting. In this project we considered non-pneumatic tire based on circular pipe, spline, double spline. The spokes of non-pneumatic tires are crucial for the rigidity and resilience under cyclic loading of compressed stress. The challenge is to design highly rigid, highly durable materials. 3. Methodology. CAD model. The measurements of the tire of Cessna 172 aircraft are obtained from Goodyear Aviation Company Tire Data Book. The aircraft's tire is classified into types. Most of the aircraft's tires are of Type 3. The type of tire that is being used for Cessna 172 is referred as 6.0026, where its geometric data is given below. The NPT is classified into types depending on number of layers of structural spokes. There is single layer, multi-layered. Here we design 3 different spokes, pipe, spline, and double spline. Here as we see the spline structured spoke is a single layered NPT, while double spline and pipe structured spokes are multi-layered NPT. Spline structure is patterned with a radius of 196.7 mm and thickness of 4 mm, in clockwise direction. The double spline is patterned with radius 196.7 mm and thickness of 4 mm in clockwise and counterclockwise as well. The pipe structured spokes are patterned with a radius of 10.51 mm on the first layer. Here we need to note that the radius of pipe shrinks as it reaches to the hub of NPT. It is done to increase the weight of tire by increasing the number of layers in spokes. The radius of each pipe of NPT shrinks accordingly with the radius of the whole tire. All the 3 spokes are of 150 mm section width. In the above figure 3.1, figure A represents how to design spline structured spokes, figure B, C represents the design procedure for double spline spoke structure, figure D gives the geometric data required to design pipe spoke structure. Analysis. The FEM is a numerical technique for solving differential equations that is described or can be solved for minimization of functions. In finite elements, functions approximating is determined using the nodal values of a searched continuum. The continuum or physical problem is transformed into a small finite element problem that is discretized with unknown nodal values. FEM is a computer program used to analyze a material and find out how stresses affect the load design or material. Material properties. The materials for NPT tires used in this analysis include aluminium alloy, high-strength steel, polyurethane, and rubber. The main reason for the selection is because they have a wide range of mechanical properties such as high rigidity and strength, high flexibility, hyperplastic resistance, high temperature resistance and other factors. The table 3.2 gives the materials assigned to each part and its properties. The internal surface of the wheel is fully restricted all the way, as the hub of the wheel is fixed and acting as a permanent support for the wheel. In Y direction on the outer surface of a wheel, the surface load of 7,248 N is applied, because 7428 N is the maximum braking load capacity of Type 3, 6.0026 tire. 5. Conclusion. The linear static analysis of NPT had been carried out. The von Mises stress value obtained in static analysis for all 3 models are 53.97 MPa, 55.395 MPa, 57.564 MPa respectively for double spline, pipe NPT, which are under permissible limits of material properties, which concludes that the structure is safe. The modal analysis indicates that the design requires some improvements which can increase the life of the wheel.